Okay, so remember letter A is crest, it's the top point of the wave. Letter B is the trough, the bottom point of the wave. Letter C is amplitude, so half of the height of the wave. And then finally D was wavelength, which we measure from one crest to the other. Okay, so moving on to number 6 on your worksheet, it asks us to use these 5 pictures to answer A, B, C, D, and E. So on letter A, it says waves P and Q have the same blank, but wave P has twice the blank of wave Q. So we're only going to look at the first 2 waves here and here. And excuse my dog coughing in the back. But on this wave and this wave, we're using those words that we learned in questions 1 through 5. So crest, amplitude, wavelength, trough, frequency. And we're trying to figure out what could go in the blank. So what does P and Q have in common? And you can start with the first word. Their crest, we can't really say anything about their crest. Yes, they both have crest, but they don't necessarily have the same crest because their height is different. They don't have the same trough. Their amplitudes are different because their heights are different. So the word that works here is, you could say either wavelength or frequency. So I'm on letter A. Wavelength or frequency can go in the first blank. So let me explain that real quick. So on P and Q, from here to here, that's our wavelength. From here to here, that's our wavelength. So our wavelength, if you had a ruler, you could see it a little better, but our wavelength, these lines, are actually the same. Also, assuming that these 2 waves happened in the same amount of time, you would see that they have the same amount of waves. So there's 1 wave, 2, 3, 4, 5, 6, and 7. This one also has 7. 1, 2, 3, 4, 5, 6, and 7. So either one of those words work for the first part. The second part says, but wave P has twice the blank of wave Q. So the one thing that should jump out as being different is this wave is a lot taller than these waves. And remember that height is the same thing as amplitude. So the second blank on letter A is amplitude. Go ahead and pause the video, and I want you to try letter B now that you've seen an example. And again, use the words from questions 1 through 5 and see if you can figure out what goes there. Okay, so for letter B, you used wave Q and wave R. And you're looking for something that they have in common because it says waves Q and R have the same blank. So, what they have in common is actually their height. So this wave, you would take half of its height for the amplitude. So the amplitude is this piece. And then on this one, if I wanted the height, again, it would go here, but I take half of it. So they have the same amplitude. The next part, it says, but wave R has twice the blank. So one thing that pops out is this wave is a lot longer. It's not as frequent. This one has a higher frequency because the waves are more frequent. But wave R has twice the wavelength. So remember, from here all the way to here is a wavelength. Whereas on this one, from here to here is our wavelength. So the wavelength is twice as much with letter R. On letter C, it says wave blank shows a steady frequency but changing amplitude. So we're looking for the one where waves start pretty frequently. They're happening at a pattern. but their height is changing. So the only one that has a height that changes is T. On the next one, letter D, it says wave blank shows a steady amplitude, so a steady height, but a changing frequency. So it means the waves might be going fast and then slow, fast and then slow. So the correct answer to that one is wave S. Their amplitude or their height is all the same. They're not getting smaller or shorter, but the frequency isn't the same. So here, these are a little closer together, whereas here they're a little bit more spread apart. And then next one, we're on letter E. It says waves blank and blank have a low amplitude and steady frequency. So amplitude is height. So the ones with small height are Q and R. And they also have steady frequencies, which means their waves are occurring at a steady pattern. So Q and R. Moving on to number 7. Okay, moving on to question 7, letter A. It says, is this wave transverse or longitudinal? So I went back to the very first slide I showed you. Remember, transverse waves go up and down, which is what we were working on questions 1 through 6. On question 7, you see a wave looking like this, so it is a longitudinal wave. So go ahead and answer letter A. And we're going to look at the parts of a longitudinal wave. Longitudinal waves are still mechanical waves, but their energy, instead of going up and down, it's just moving across left to right. So the longitudinal waves actually don't have an up and down. What they're trying to show you here is in some parts of the longitudinal wave, you have these pieces that are super close together. If something's really close together, that means it has more energy there. Whereas when it's more spread apart, it means there's not as much energy there. So this part where there's lots of coils all together means there's lots of energy, and that word is compression. And then if you look at part I, there's not a lot of coils, so there's not a lot of energy, and that's called a rarefaction. Sorry, faction, not fraction. And then finally, just like with transverse waves, you still have where a wave begins to where another one can begin, and that's considered the wavelength. So we're not going to talk or spend a lot of time on longitudinal waves, but the one thing that's super important for you to know is that with transverse waves, remember they go up and down, whereas longitudinal waves look like this. Their energy is going just left to right. And we're going to spend more time on that when we take some more notes on waves. But I want you just to have a basic knowledge between those two. Okay? Go ahead and stick this notes page in your binder and read the board for further directions.